Now it's a form where you have a linear by quadratic, and this type of questions are done by writing our numerator, which is a linear function, is equal to a time derivative of denominator, which is 2x minus 9 plus b. Now here a and b are some constant. So if we can find the value of a and b, then we'll write our 6x plus 7 in these two terms, and then split our whole integral in two parts, say I1, I2, and we'll find the answer. Okay, let's first find the value of a and b. So what we are going to do is 6x plus 7 remains as it is, and we open the bracket on right side. Okay. Yeah, now we would equate the coefficient of x and constant term. Look at here. Coefficient of x here is 6. So this will imply 6 is equal to 2a. This further implies a is equal to 3. So we got our value of the first constant a. Now we are going to equate the constant term, and the constant term here is 7, you see. And the constants are here the terms that are free from variable x. This means we can write 7 is equal to negative 9a plus b, and this is going to be replacing the value of a. 7 would be equal to minus 27 plus b, and taking this 27 to the other side, we would get b is equal to 27 plus 7. Yes, and 27 plus 7 is 34. So we got the value of b, which is 34, and we already have value of a. This means we can now write our question I. If we represent this question by I for integral. Now we can write our integration as I is equal to integration of a times 2x minus 9. A means 3 times 2x minus 9 divided by the denominator, which is x squared minus 9x plus 20, plus b, which is 34. 34 divided by, again, this denominator, which is x squared minus 9x plus 20 dx. Okay, so this is our integration now. So can we write our I is going to be 3 times, let's say this integral, we take out this constant, and then the remaining is I1. 3 times I1 plus take away this 34 also, 34 times, let's say that integral as I2. Now our job is to find I1 and I2 separately, and then club them together to find this I. Okay, so we would remember our I is equal to 3I1 plus 34 I2. Okay, I is equal to 3I1 plus 34 I2. Now we are going to find I1 and I2 separately. Let's see what I1 was. I1 was 3, okay, 3 we had taken common, so just this is 2x minus 9 divided by x squared minus 9x plus 20 and square root over 8. Okay, and this type of question, we simply put our denominator, which is x squared minus 9x plus 20 is equal to t, and that gives us our numerator 2x minus 9. That was whole region of substituting or transforming our numerator in that form, no? And this becomes easy to integrate. So 2x minus 9 dx is going to be dt. That's giving you, okay, now your I1 would look like integration of dt divided by square root t. And integration of square root is 2 root t. If you wish, you can check all this step. It will become integration t to power negative half dt, and then you'll apply the formula and you will end up getting 2 square root t plus c. And if you retain the value of t, that would be equal to 2 times square root of x squared minus 9x plus 20. You should note down all these things because I am going to clear this to find I2. Okay. Now I2 is integration of dx over under root of x squared minus 9x plus 20. Now, in this type of question, we make the perfect square in the denominator first, and this integral is going to look like dx over x minus half the coefficient of x minus 9 by 2 square, and we add half the coefficient of x, which is 9 by 2 square. So we are going to subtract 9 by 2 square also. 9 by 2 square and plus 20. And this is all over square root, which would be dx by, now this thing is x minus 9 by 2 squared. And we want to write these numbers together, which is 81 by 4 negative and plus 20. Minus 81 by 4 plus 20. Well, this is now dx divided by x minus 9 by 2 squared minus 1 by 2 squared, because this will be 1 by 4, which can be written as 1 by 2 squared. Now this is of the type x squared minus a squared. 1 by under root of, under root sign is there, under root sign is there. So under root sign is all over this expression. Now it's going to look like, okay, we can put x minus 9 by 2 equal to t also. What we can do is, we can put x minus 9 by 2 is equal to t. That will give you dx is equal to dt. Then you would retain the value of t, no? And your I2 would look like, dt over t square minus under root t square minus half square. Okay. Now, which is, we have the formula for a 1 by under root x square minus a square. Yes, we will apply that. So our I2 is, the formula is log of t plus under root t square minus a square plus c. This is the formula of 1 by under root x square minus a square. Now, we would retain the value of t, and I2 would look like log of x minus 9 by 2 plus under root. In place of t, we are going to write x minus 9 by 2 square, x minus 9 by 2 square minus a square. Okay, in place of a, we had half. Half square means t squared minus 1 by 4 and plus c. T squared, just 1 moment. T squared minus 1 by 4 and plus c. Since this expression here, x minus 9 by 2 whole square minus 1 by 4, we obtained by writing our denominator, which was quadratic in the denominator, x squared minus 9x plus 20 in perfect square. So this should give you x squared minus same expression. Yes, means our I2 is going to look like log of x minus 9 by 2 plus this expression. If you expand, you will get that only. You will get x squared minus 9x x squared minus 9x plus 20. Okay, and plus, since this is I2, let's say this is C2, C2, C2. And finally, we are asked I. And we know if you are writing everything, you must have that I. I was actually 3I1, 3I1 plus 34I2. Okay, so we are going to put the value of I1 and I2 in this. So which is equal to 3. Value of I1 was, it was 2 times 3 into 2 times under root of this equation, x squared minus 9x plus 20, and plus 34 time under root of 32 time this expression, sorry, 34 time log of x minus 9 by 2 plus square root of x squared minus 9x plus 20 plus c. See, we write just one constant because whatever the constant comes, c1, c2 will club together to give you this c. So this is your answer.